Assalamu alaikum students, hope you all are fine. I am your teacher Afifa and this is the lecture of physics for class 8th. Today we will do chapter 2. This is the outline of today's lecture and we will use the physics book for class 9. So please open page number 40 of your books. Graphical analysis of motion. This is the topic of today's lecture. First, we have to discuss the title of this topic. As you can see, the word graph has been used here. We have used the word graph everywhere, like photograph in your daily routine. So graph means picture. Whenever we are discussing graphical, it means we are discussing the pictorial form of that thing. Here we are going to discuss the graph of motion. So in graph of a motion, we have a picture. As you can see, it is drawn here. It is a relationship between two quantities. One quantity is drawn on x-axis, whereas the other one is drawn on y-axis. One is independent and the other is the independent quantity. First of all, we will study distance time graph. As you can see from the title, the graph is between distance and the time. Time is always drawn on x-axis, whereas the distance is drawn on y-axis. Here is a question: why we study distance time graph? What we can get from this graph? So basically this graph gives us the speed of a body. The ratio of distance and time is a speed. As we can see this thing from the formula, speed is equal to distance covered divided by the time taken by the body. So this graph is helpful in finding the speed of a body at particular point from the graph. But here we have some more important points. We should always be very considerate about them during drawing the graphs. The scale setting, we have to set the scale properly and then mentioning the quantities along with their units on their respective axes. As you can see, the time has a unit minute, whereas the distance has the unit meter. So whenever someone sees this graph, they know that this quantity or this graph is between which unit. Now we will see the distance time graph when the object is at rest. When something is at rest, it means it is not changing its position with respect to its surrounding. It is in stationary state. It is not moving at all. As you can see from this graph, there is a blue straight line. It means the time is passing, but the distance is 100 meters throughout this time duration. It means the body remains at 100 meters. It is not changing its position, so it is not covering any distance. The next graph is of the object which is moving with constant speed. Here we have to discuss what is constant. Basically, when something is not changing, it remains unchanged, that thing is called constant. When the object is covering equal distance in equal interval of time, that graph is called constant speed graph, because at every point we will get the constant speed or unchanged speed. Now, how we can see that the speed of a graph remains unchanged? So the slope of the graph basically gives us the speed of object at any particular. What is a slope? As you remember, the slope is the ratio between vertical change and horizontal change. How the slope gives us the speed of an object. If you remember, previously we have discussed that the vertical change or the quantities on vertical axis divided by the quantities on horizontal axis gives us the speed at particular point. So slope of line AB is the change of vertical axis and the horizontal change, At vertical axis we have the change distance EF, whereas on horizontal axis we have the change CD. If we divide their numerical values, we will get 2 meters per second, which is the speed of an object at that slope. The next graph is object moving with variable speed. What is variable speed? Variable means when something is changing continuously, it is not constant, it is varying continuously in a random way. When object doesn't cover equal distance in an equal interval of time, it means its speed is not constant, it is variable. At particular instant, if its speed is 10 meter per second, and at another instant its speed is 20 meter per second or 30 meter per second, or it decreases to 5 meter per second, then the speed is not constant, it is varying continuously. Here is the graph where time is on by x-axis and the distance is on y-axis. As you can see, the pink line, it is changing continuously, so the graph is variable. How we can find out the slope on this random line or a random graph? With the help of tangent, we can find out the slope with a graph of variable speed. What is tangent? Tangent is a straight line that touches the graph at a one point, so we will get the speed of a body at that one. Now we will discuss the mathematical way of finding the speed of a body, and with the help of tangent at a particular point on variable speed graph. As you can see, the pink line is showing the graph, and how we can find out the speed of a body at point P. As you can see, this line is showing the tangent. It is a line which is touching this graph only at point P, and we will find out the speed of a body at point P. So the slope of tangent at point P is Rs. Rs is showing the distance, whereas the Q is showing the time. By dividing these two ratios, we will get the speed of a body 3 meters per second. The speed is higher at the instant when the slope gives us the greater value, whereas the speed is 0 at the instant when the slope is horizontal. Now we will study speed time graph. This is the speed time graph, and as you can see, along x-axis we have time and along y-axis we have velocity. Make sure whenever you are writing the quantities along with their axis, you have to write the units with them. Now there is a question that why we study speed time graph. So basically, speed time graph tells us about the acceleration of a body. How we can find out the acceleration? As you know the formula of acceleration. Acceleration is the change in velocity with divided by time, and with the velocity is given here, the time is also available, so we can easily find out the acceleration of a body. And we can also find out the distance traveled by an object, because the formula of distance is s is equal to velocity multiplied by the time. So in this graph we have the values of velocity as well as time, so we can easily find out the values of distance. Now we will study the speed time graph for the objects which are moving with constant speed. As you know, constant means when something is not changing, that is called constant. So when the speed of a body is not changing, the body is moving with same speed during a particular time period. That is called constant speed. As you can see in the graph, there is a pink line which is showing the constant speed, and whenever there is a straight line parallel to time axis or x-axis that shows the constant speed graph. Now there is a very important thing, that is the graph interpretation, and you should know how to interpret a graph. So please listen carefully. Whenever you are when you start analyzing the graph, you should start from 0. So at when you start moving, the time starts spinning. After 5 seconds, you have seen the velocity or speed of a body is 4 meter per second, and in next 5 seconds when you observe, it's still 4 meter per second, and throughout the time during 20 seconds the speed of a body is 4 meter per second. So from this graph we can easily analyze that the velocity or speed of a body is constant. Now we will study another graph in which the object is moving with speed and the speed is changing uniformly. Uniform means basically when something is evenly, smoothly or equally. So when the change in speed is equal to the change in time interval, that is called uniformly changing speed. This is the graph of uniformly changing speed. The body is moving and its speed is changing uniformly, and the pink line shows the motion. So the graph interpretation of this graph is, if you observe the motion of a body in first 5 seconds, the increase in velocity is 2 meter per second. In next 5 seconds it is again 2 meter per second. 4 minus 2 is 2 meter per second. So again the change in speed is 2 meter per second, and in next 5 seconds the speed change in speed is also 2 meter per second. So from this thing we can easily understand that in this graph the speed is changing uniformly. So when the velocity is increasing uniformly, the body has uniform acceleration. Okay students, now it is a activity time, so please open your copies, take out your pencils. Example 2.7. This is the statement of example 2.7. Find the acceleration from speed time graph as shown in figure 2.23. This is the graph given here and we have to find out the acceleration. If you remember how we can find out the acceleration, by using the concept of slope, because slope gives us the acceleration in velocity time graph. And what is slope? If you remember, we have discussed it thoroughly, that slope is the ratio between vertical change and horizontal change. So acceleration is equal to slope of the line AB, whereas the slope is change in velocity divided by time interval taken by the body. So in point A and B, the change in velocity is 4 meter per second minus 2 meter per second, whereas the change in time interval is 10 second minus 5 second. So from this formula we got the value of acceleration 0.4 meter per second square. Example 2.8. The statement of example 2.8 is, find the acceleration from speed time graph as shown in figure 2.24. So here we have to find out the acceleration. But first please observe this graph, that at point 0, the initial point, the velocity of a body is 6 meter per second, and eventually after 5 seconds it has become 4 meter per second. After 10 seconds it is 2 meter per second, and after 15 seconds the velocity of a body is 0 meter per second. So from this graph we can easily understand the velocity of a body is decreasing. The change in velocity is negative because the body is deaccelerating. So when we will find out the slope, we will find out the acceleration, there will be a negative sign with it because the body is deaccelerating here. So this is the solution. Acceleration is equal to slope of c and d, the change in velocity divided by the change in time interval. So if you see the value of velocity at 10 seconds, that is 2 meter per second, and the value of velocity at 5 seconds is 4 meter per second. So this is the final value and this is the initial value. So final minus initial change is 2 meter per second minus 4 meter per second divided by 10 seconds minus 5 seconds, and by solving this we will get the acceleration is equal to minus 0.4 meter per second square. The body is deaccelerating here, the velocity is in decreasing, that is why we have a negative sign in our answer. Example 2.9. The statement of example 2.9 is a car moves in a straight line and the speed time graph of its motion is shown in figure 2.25. This is the figure, and here we have to find the acceleration during first 10 seconds for this phase from point O to A, and the deceleration during the last 2 seconds from point B to C, and the total distance traveled from point O to C, and the average speed of the car during its journey from point O to C. First we will do part A, in which we have to find out the acceleration for first 10 seconds. As you know, acceleration is equal to change in velocity divided by the time interval. The change in velocity is, the velocity at point A is 16 meter per second. So final velocity is 16 meter per second, whereas the initial velocity is 0 meter per second. So their difference divided by the total time interval, which is 10 seconds, gives us the acceleration. 16 minus 0 meter per second divided by 10 seconds give us 1.6 meter per second square acceleration. In part B, we have to find out acceleration for last 2 seconds from point B to C. In this case, B is the initial point and C is the final point. So acceleration is change in velocity divided by time interval. The time interval is 2 seconds, whereas the change in velocity is final velocity minus initial velocity. The velocity at point C is 0 meter per second and the velocity at point B is 16 meter per second. So their difference gives us minus 16 divided by 2 second, which is equal to minus 8 meter per second square. The negative sign here in the answer is indicating that the body is deaccelerating, means its velocity has decreased. In next part, we have to find out the total distance traveled by the body from point O to C. O, A, B, C. As you know, this shape is a trapezium, and from the area under the graph, we can find out the total distance traveled by the body. So the area of trapezium is 1 divided by 2 multiplied by sum of parallel sides multiplied by the height. This is the height, and AB and OC are the parallel sides. So their sum is from point O to C. The value is 0 to 30 seconds. Whereas point A to B, the value is 18 seconds. So by putting these values and solving them, we will get the total distance traveled by the body is 384 meters. There is the one point more, that the height is 16 meter per second. How is it? As you can see clearly, The body has reached maximum point along velocity axis is 16 meter per second. So the total height of this trapezium is 16 meter per second. In last part we have to find out the average speed, and the average speed is total distance covered divided by time taken. As you know, the body has taken total 30 seconds, and previously we have found the value of total distance covered by the body, that is 384. So 384 divided by 30 seconds gives us the average speed of 12.8 meter per second. So the body has average speed 12.8 meter per second throughout this journey. Now we will do exercise question answers. So the question number 2.7 is sketch a distance time graph for a body starting from rest. How will you determine the speed of a body from this graph? So first of all we have to sketch the graph, and then we will find out the speed of a body from that graph. So first you have to draw the graph base, and you have to mention the time along x-axis and distance along y-axis with their respective units, and you have to set the proper scale. This distance of 5 seconds should be equal to this distance, and all of them should be equal. After drawing this, after setting the proper scale, now you have to draw the motion of a body. In first 5 seconds the body has covered 10 meter, in next 5 seconds the body has covered 20 meter. So this is the graph of a body which is moving with uniform speed. Now we have to find out the speed from this graph. So the body is covering equal distance in equal interval of time. So by using the concept of slope, we can find out the speed from this graph. Here we have marked the points, that point A and B. Between these points, we will find out the speed. Now speed is equal to slope of AB, whereas slope is the ratio between vertical change and horizontal change. Vertical, the body has the change from point F to E or EF, whereas the horizontal change is between point C and D. So at point F we have the value of distance 30 meters, and at point E it is 10 meter. So we will subtract them, and for time interval we have value 5 second at point C, and at point D it is 15 seconds. So 15 seconds minus 5 seconds give us 10 seconds. So solving this, we will get speed is equal to 2 meter per second. Question 2.8. What would be the speed time graph of a body moving with variable speed? If you remember, when the body is not covering equal distance in equal interval of time, then the speed of a body is variable. This is the graph of a body having variable speed. As you can see, the line is not straight, it is a curved line. So by using the concept of tangent and slope, we will find out the speed. So we have to find out the speed at point B. So by drawing a tangent, as you can see, this dotted line is touching this curve only at point P. So we are finding the velocity at point P. Slope of tangent at point P is RS vertical change divided by horizontal change, which is QS. So the value of RS is 30 meters, whereas the value of QS is 15 minus 5, which is 10 seconds. So by solving them, we will get the value 3 meter per second. So this is the speed of a body which is moving with variable speed. Next question is, which of the following can be obtained from speed time graph of a body? Initial speed, final speed, distance covered in time t, and acceleration of motion. This is a speed time graph. If you remember, we have done a numerical related to this graph as well. So from this graph we can easily find out initial speed. We can find out the final speed by using the formula of acceleration, final velocity minus initial velocity divided by time interval, and we can find out the acceleration, initial velocity and final speed from this formula. And the distance covered in time t, we can also find out this thing as well by using the area under the graph. So all above mentioned things can be found from speed time graph. The next question of your exercise is 2.14. Sketch a velocity time graph for the motion of a body. From the graph explaining each step, calculate the total distance covered by the body. In velocity time graph, we can easily find out the distance covered by the body. But here we have two cases. Number one, when the body is moving with constant velocity. This is the graph of a body in which we have constant velocity. So by using simple formula, velocity is equal to distance covered by the time. V multiplied by t is equal to d, or s is equal to vt. The next thing is, when the body is moving with variable velocity, here the velocity of a body is variable. So by using the concept of area under the graph, we can find out the total distance covered by the body. Here we have also two options. Number one, by using the simple formula, V multiplied by t is equal to d. Here we have to put the value of average velocity. Initially the velocity is 0 meter per second. Finally it is v meter per second. Here we don't have any particular scaled value, so we are taking the final velocity just as v. So average velocity is v divided by 2. By putting the values in this formula, v multiply by t is equal to d, we get d is equal to v divided by 2 multiplied by t, which is equal to half vt. Or the next method is area under the graph. Here the area under the graph is a triangle. The area of triangle is half base multiplied by height. So the base is time, whereas the height is velocity. By putting the values in area of a triangle, base as time and height as velocity, we will get the area of triangle, which is half vt. As you can see, these two values are similar. So by using any one method, you can find out the distance covered by the body. Students, please open page number 40 of your books and take the highlighter to mark the important points for objective. In graphical analysis of motion, mark the first line. This is the definition of graph. Graph is a pictorial way of presenting information about the relation between various quantities. I am repeating, graph is a pictorial way of presenting information about the relation between various quantities. Now mark the definition of variables. This is the next line. The quantities between which a graph is plotted are called variables. The quantities between which a graph is plotted are called variables. Now come to the next topic, distance time graph. On second line of this paragraph, the term distance and displacement are used interchangeably when the motion is in a straight line. I am repeating, The term distance and displacement are used interchangeably when the motion is in a straight line. As you know the definition of displacement, it is the shortest distance covered by the body, whereas the distance is the total length of the path. So when the body has covered a smallest distance, and that is also the displacement for that path, so we can use these two terms interchangeably. And mark the next line. If the motion is in a straight line, then the speed and velocity are also used interchangeably. I am repeating, if the motion is in a straight line, then speed and velocity are also used interchangeably. Obviously, as when the speed has distance in its formula and velocity has displacement in its formula. So when the term distance and displacement are interchangeable, obviously their formulas, the speed and velocity, are also interchangeable, and this is the only case when the motion is in a straight line. Now come to the next topic, object at rest. Third line, a horizontal line parallel to time axis on a distance time graph shows that speed of object is 0. A horizontal line parallel to time axis on a distance time graph shows that speed of the object is 0. Also mark the figure 2.18 and its caption, distance time graph when the object is at rest. Now come to the next topic, object moving with constant speed. Mark the first line. The speed of an object is said to be constant if it covers equal distance in equal interval of time. I am repeating, the speed of an object is said to be constant if it covers equal distance in equal interval of time. This is also the definition of constant speed. Now mark the graph and its caption, figure 2.19, distance time graph showing constant speed. Now open page number 41, object moving with variable speed. Mark the first line. When an object does not cover equal distances in equal interval of time, then its speed is not constant. I am repeating, when an object does not cover equal distance in equal interval of time, then its speed is not constant. Now mark the fourth line of this paragraph. The slope of the curve at any point can be found from the slope of tangent at that point. The slope of the curve at any point can be found from the slope of tangent at that point. This is a graph of variable speed, and we have discussed it thoroughly that to find the slope we used the tangent which touches the graph or curve at only one point, and by finding the slope at that particular point we can find out the speed. Okay, now also mark figure 2.20 and its caption, distance time graph showing variable speed. Now in the last three lines of object moving with variable speed, please mark it. The speed is higher at instant when the slope is greater. Speed is 0 at instant when slope is horizontal. I am repeating, the speed is higher at instants when the slope is greater. Speed is 0 at instant when slope is horizontal. If you look at this graph, you can easily understand these lines. Obviously the speed is higher at instant when the slope is greater. When the slope is greater, when this thing is greater, obviously the body has covered more distance, so its speed is also greater. But when the speed is 0, the slope is horizontal. Obviously when the slope is like this horizontal, it means it has covered a minimum distance or has covered no distance. So in this case the vertical change is 0, so the slope of the body will also be 0, because slope is vertical change divided by horizontal change. So now you have got the point that the speed is higher at instant when the slope is greater, and the speed is 0 at instants when slope is horizontal. Now come to the point, page 42. Object moving with constant speed. Please mark the last line. A straight line parallel to time axis represents constant speed of the object. I am repeating. A straight line parallel to time axis represents constant speed of the object. Please mark figure 2.22, speed time graph showing constant speed. Now mark the first line of object moving with uniformly changing speed. Also write, instead of let, write when the speed of an object changing uniformly. In such cases, speed is changing at constant rate. I am repeating, when the speed of an object changing uniformly. In such a case, speed is changing at constant rate. Now come to the fourth line. A straight line means that object is moving with uniform acceleration. A straight line means that object is moving with uniform acceleration. Slope of the line gives the magnitude of its acceleration. Slope of the line gives the magnitude of its acceleration. Now also mark figure 2.23, graph of an object moving with uniform acceleration. Now open page number 43 and mark the graph given on the right side. Figure 2.24, graph of an object moving with uniform deceleration. This is the graph of a body which is deaccelerating. Now come to the heading distance traveled by a moving object. Mark this paragraph. The area under a speed time graph represents the distance traveled by the object. The area under a speed time graph represents the distance traveled by the object. If the motion is uniform, then area can be calculated by using appropriate formula for geometrical shapes represented by the graph. This is a very important point, that when the body is moving uniformly like this from point O to A, it is moving uniformly, then we can easily find out the area under this graph geometrical shape, because when you join the point A to horizontal line, it will give you a triangle. So you can easily find out the area under the graph, which is area of a triangle, and by using this thing you can find out the total distance traveled by the object. So this is very important point. When we have uniform motion, we can find out the area by using appropriate formula of geometrical shape. Hopefully students, you have understood everything in this lecture, every single detail, and you have marked the objectives on your book as well. Please practice everything you have studied, every numerical, every example and question answers of your exercise. And this is the summary of this lecture. Please review it and make your concepts better and clear. Thank you so much. Allah Hafiz.